Good morning, student. Today we discuss VSEPR theory. The full form of VSEPR theory is valence-shell electron pair repulsion theory. This theory is helpful for predicting the geometry of molecule, especially the compound of p block element. The main postulate of this theory are as follows. Number one, the shape of molecule containing only two atoms is always linear. I repeat again, the shape of molecule containing only two atoms is always linear. Number two, for a molecule containing three or more atoms, one atom is called central atom to which the atoms are linked. Number third, if the central atom is linked to similar atoms and is surrounded by the bond pairs of electron only, the repulsion between the bond pair of the repulsion between them are similar. As a result, shape of molecule is symmetrical and have regular geometry. I repeat it again. If central atom is linked to the similar atom is surrounded by the bond pair of electrons only, the repulsion between them are similar. As a result, shape of molecule is symmetrical and have regular geometry. Fourth point, if central atom is linked to different atom is surrounded by bond pair as well as lone pair of electron, the repulsion between them are different and the molecule is irregular or distorted in shape. It should be noted the repulsive interaction between lone pair is most and the bond pair is least. Number fifth point, the exact shape of the molecule depend only the total number of electron pair present around the central atom. For systematic study of VSEPR theory, now let us draw a chart which consists of total number of electron pairs. First is the total number of electron pair, geometry of electron pair. Here the bond pairs, here the lone pairs, here the geometry of molecule, and thereafter example. Let us draw a chart for systematic study of VSEPR theory. According to this chart, we divide the table into these following parts. Now let us suppose number of electron pairs are 2 as we described earlier. When the number of electron pairs are 2, the shape will be linear. The geometry of electron pair are indicated like this manner, in which maybe 2 lone pair or 2 bond pair. Bond pairs are 2, lone pairs are 0. The geometry of molecule will be linear. The geometry of molecule will be linear, illustrated by this one, and the best example of it is CO2. I repeat it again. If the total number of electron pairs are 2, geometry of electrons pair are like this manner. Here the number of bond pairs are 2, lone pairs are 0. Geometry of molecule will be linear, and the example of CO2. Now let us consider the number of electron pairs are 3. If number of electron pairs are 3, geometry of molecule may be illustrated by this manner. If number of bond pairs are 3, lone pairs are 0, the shape of molecule is represented like this manner, that is called trigonal planar, which contain only 3 bond pair, and the example of it is BCl3. And the example of this is BCl3, or we can write it BF3. If in a similar manner the bond pair are 2 and the lone pair is 1, the geometry of molecule is depicted like this manner. Here this indicate one lone pair and these are two bond pair. The shape of molecule is someone bent and the example of it is NO2 and the example of it is NO2. So here we discuss total number of electron pair are 2, the geometry of electron pair like this manner, total number of bond pairs 2, lone pair 0, the geometry of molecule will be linear and the example is CO2. If total number of electron pairs are 3, geometry of electron is this, bond pair are 3, lone pair 0, geometry of molecule depicted like this manner, triangle planar and the example of BF3 or BCl3. If in a total number of electron pair 3, bond pair are 2, lone pair is 1, then shape will be bent. Example is NO2. Now let us proceed further. If total number of electron pairs are 4. Now let us consider if total number of electron pairs are 4. Geometry of electron pair illustrate like this manner. Total number of bond pairs are 4, lone pair is 0. The shape of molecule is depicted like this manner. The shape of molecule depicted like this manner. An example is CH4. If total number of electron pair 3, bond pair are 3, lone pair is 1, the shape of molecule is illustrated as 1, 2, 3 bond pairs and one lone pair is there like this manner and the example is NH3, that is ammonia. In ammonia molecule one lone pair is there which is indicated by this manner. Now if total number of electron pair 4, bond pairs are 2, lone pairs are 2, the shape of molecule is illustrated by this manner. Here the 2 bond pair, 2 lone pair. The shape of molecule is bent and the example is water. And the example is water. So here we discuss the case when the total number of electron pairs are 4, geometry of electron illustrated by this manner, bond pairs are 4, then geometry of molecule will be tetrahedral. If bond pair 3, lone pair 1, geometry of molecule will be someone bent. Example is NH3, the actual shape is pyramidal due to distortion of lone pair. If bond pair are 2, lone pair are 2, due to lone pair repulsion is more, the shape of molecule is bent and the best example of it is water. Now let us discuss total number of electron pair 5. When total number of electron pairs are 5, the following situation may be arises. It is represented like this manner also. 1, 2, 3, 4, 5. Now various situations are there. Total number of 4 situations may be exist if total number of electron pair is 5. Now suppose all are bond pair. Suppose all are bond pair, 0 lone pair is there. The shape of molecule will be, trigonal bipyramidal. The best example of it is PCl5. Suppose bond pair are 4, lone pair is 1, then shape will be the shape of molecule will be like this manner and the best example of it is SF4. Suppose the bond pair is 3, lone pair is 2, then shape will be T shape. The shape will be T shape. Example is ClF3. T shape. If the bond pair are 2 and the lone pair are 3, then the geometry of molecule is represented like this manner also. bond pair are 2, lone pair are 3, the geometry of molecule is somewhat linear, and the example is XEF2. So these are the situation when the total number of electron pairs are 5. If bond pair are 5, all are bond pair, the geometry of molecule is like this manner. And example is PCl5. If bond pair 4, lone pair 1. The example is SF4. If bond pair is 3, lone pair is 2. Example is ClF3. If bond pair is 2, lone pair is 3. Greater repulsion there in molecule. The example is XeF2. Now let us discuss the situation in which total number of electron pairs are 6. If total number of electron pairs are 6, the following three situations may be there. The three situations may be there. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. Bond pair are 6, lone pair is 0. The shape of molecule is like this manner, or you can say it to be octahedral. And the example of is SF6. If bond pair are 5, lone pair is 1. If bond pair are 5, lone pair is 1. The shape of molecule illustrated like this manner. It is distorted tetrahedral. Example is, and the best example of it is ClF5. The best example of it is ClF5. Now let us consider the situation in which bond pair is 4, lone pair is 2. If bond pair is 4, lone pair is 2, the shape of molecule illustrated like this manner. And the example of it is XeF4. So these are the situation in which the total number of electron pair are 6. If bond pair 6, shape will be like octahedral. Example is SF6. If bond pair 5, lone pair 1, distorted octahedral geometry will be there. An example is ClF5. If bond pair 4, lone pair 2, distorted octahedral geometry will be there again, in which greater repulsion, electron repulsion between lone pairs, and the example is XeF4. Thank you very much.